I'm getting chilly.
Right. Right, I see that at least our construction is fine. People are making good constructions, and then let's call this D. We're just doing this one more time, and then this will be in this angle. We'll have O1, O2, and then we say we're going to call this P1 and P2, and then we have set in triangle P, OA on the other side. Let our P1 be equal to X, and then this will then in turn become X, and then we'll say your P1 equals to A. What is the reason why it was equals to A? Angles opposite, equal sides, or equal radiuses, right? Because we know this is equals to that, right? So you can also mention that before that to say I know that OP is equal to OA because those are radiuses of the same circle, and then the same will apply on the sides. So we have this as X, and then we'll use the exterior angle to say if A1 is equal to X, then we'll have O1, which is this angle. When you look at this triangle, this becomes the exterior angle. So our O1 is equal to 2 times x, because the exterior angle is equal to the sum of the two interior angles. And I see that most of us have got it right. And then you can also come this side. To say now in triangle POA, POB, we know that OP is equal to OB, because those are radius. And then we have another angle, let P2 now be equal to Y. This will be our Y. And then we'll say B, your angle P2 is also equal to B. Angles opposite equal sides or equal radii. And then O2, if this is Y, your O2 will also be equal to 2Y, which is exterior angle of a triangle. This is also, don't forget that is in the side, exterior angle of a triangle. We're just making sure that everybody is on par. We have mastered this proof, né? But we're just making sure. And then when you add O1 plus O2, they need to give you 2x plus 2y, because you said O1 is 2x and you said O2 is 2y. We take out the common factor, but when you look at O1 plus O2 is this angle. O1 plus O2 is this whole angle, which was named AOB. It's equals to 2. We take out the common factor, and then we see AOB being equals to x plus y is this angle. We see that this will be the same as 2 multiplied by A P B. And then our proof is done. Any challenges that we would like to rectify? You not mentioning the triangles will not affect your marks allocation, né? But if you can always mention it. It's just to make you to be able to see the proof properly. That's why I've also placed them on the left hand side, the other one on the right hand side, so that you can see which triangles are we actually talking about. Talking about this triangle, and we're also talking about this triangle. So it will be easy for you to see the exterior angles. So it's very important to know these proofs, and it's also very important to know how to apply them. And I said to you guys, every time when you are required to construct, you will see on the statement or on the question, they will say, proof the theorem. Prove the theorem. You see, there's proof and there's also a theorem in the same statement, which states that, and then you know that construction must take place. But if they don't say that, if they just say prove that something is a parallelogram, or prove that something is a cyclic quad, there's no need for you to actually construct. Use what information that you have. But once they say prove the theorem, so the keyword is prove and theorem in the same line, then you know that we have to construct. We are proving a theorem, so we have to construct. All right, on your notes or on your paper, the second problem is, turn the paper. Do you see that one is question 10? This is question 9. All right, that's 9.2. Let's go to 9.2 first before we go to question 10. That's good. Yes. Is it what? I want to say this one. There's a button below the blue one. Okay. Yes. Let's start with 9.2. 9.2. What I need is a diagram analysis. You can do a diagram analysis, then answer the question. What I need from you guys is a diagram analysis. So I'll give you exactly 5 minutes. So it's 8:23, 8:28. We'll now have a discussion. Try to do that diagram analysis. Actually, don't try, do it. You have 3 minutes. Make it a rainbow. Make that diagram a rainbow. Make it a rainbow. It must be colorful. Now the most important thing is to analyze the diagram. All right, let's see what we have. You will answer, you'll be given a chance to answer those questions. We have, in the diagram below, we have PQRS is a cyclic quadrilateral, and M is the center of the circle. So MS bisects PSR such that S1 is equal to S2, which is equal to 42, and then PQ is equal to SQ. So what we said is that we would like to have to see if the information that is given to us is there on the diagram. The first one is that is PQRS, the cyclic quadrilateral. Let's go and highlight PQSR. We have P, Q, and then RS. Good. This is what we have. For the fact that we have a cyclic quadrilateral, we're thinking, okay, if I have a cyclic quadrilateral, how it can benefit me is that I know that if there's an exterior angle, which I don't see this side, will be equal to the interior opposite one, and then this angle, this angle plus this angle must give me 180. They are supplementary. These are supplementary angles. So they need to give me 180 degrees. That's what must come to your head because we have a cyclic quad. What can we use? And then we also remind ourselves of the theorems that has the center. These are the theorems that has the center. When we have a center, we can use the theorem. Angle at center, twice angle at circumference. When we have a center. So these are the things that I can actually also benefit us when we have a center. So we are looking for such theorem. Is there any other theorem that has a center of a circle? Any other theorem that has to do with the center of the circle that you can think of? So I know that already I've prepared my brain to say I must be looking for this. Then you come to the diagram, you have PQ being equal to SR. Yes, PQ being equal to SR, it has been shown. So you start where there's more information, right? Good. Then we have the center of the circle. Don't forget the radiuses or the radius. So this is noted. It is not set in the diagram. This will be equal to that. These are radius. You can also note it there. Those are your radii. And then it means that when you have a radii, we know that if this is now 42, this will also be 42, right? And the reason why we say that angles opposite equal sides. And then once you have this, you can have M. You can have this M, which is 42 plus 2, 42 times 2 minus 180. This angle will be how much? 96. We'll have 96. And the reason why we got it is that we use the sum of angles in a triangle. And then this can help us to get which angle? P1. So if this is 2, this will just be 1. So the value of that will be how much? 40? 48. We'll have 48 this side. And then our reason will be angle at the center equals to 2 times angles at circumference. Right? Good. And then if this angle, let's look at this. If this is 48, can we agree that R3 will be 48?
Yes, sir. Yes, sir. Yes, sir.
Because the chords are equal, you see? This chord is subtending 48. This chord is also subtending P3, so P3 will be 48. And then the reason will be equal chords subtend equal angles. Ne? I think I made an example of if you have a star like this. If this is equal to this, then you can conclude that this angle is equal to that angle. So this is happening. This chord and this chord are equal, and this chord, if you look at this chord, is actually subtended. Is subtending this angle, and then this chord is also subtending this angle. The reason why I'm saying that the angles will be equal is because we are told that this chord is equal to that chord. And then this will give us 48. Is there anything else? Somebody is saying P2. What will be P2?
No, sir. First Q.
Yeah? We first go to Q, ne? Because we already have the whole angle. So we have Q being how much? 96. Opposite angles of a cyclic quad. We are taking out all the theorem that we might get from our diagram. And then once we have 96 this side, I had somebody saying we can now move into P2. P2 will be how much? P2 will be 36 degrees. Is it there? The sum of angles in there? Sum of angles in a triangle. Have we exhausted it? R2. R2 will be how much? They're saying R2 will be 6 degrees. Why are we saying R2 will be 6 degrees? Because when you add all these angles and these angles, they must be supplementary. Ne? So opposite angles of a cyclic quad. So this is 6 degrees. So we need to try to get as many as possible, right? We need to get as many as possible so that we can be able to solve this problem. Now, you may answer the question. I think the first question was saying, use the diagram, name given reasons, another angle equals to 42. The first question, 9.2.1, was saying, name giving a reason, another angle that is equals to 42. You will come to your diagram. This was given to you, this was given to you. You cannot mention this ones. They are 42. This is the angle that is actually equals to 42. So your answer will be this angle, and then you will write angles opposite equal side. And because, why are you saying they are equal side? Because now OR and OS are radiuses of the same circle, or the radius of the same circle. Hence we have 42 degrees. Then you take it from your diagram will guide you. It's now a 2. You don't have to go and reanalyze. And then let us try to answer 9.2.2, which was saying calculate given reasons the size of PQR. The size of PQR, and then you know that the size of PQR already your diagram is written 96, and that's the reason opposite angles of a cyclic quad. That question has been answered through our diagram analysis. And then we look at P1. We have P1, which is, they're asking you what is P1. P1 is actually 48. And then you knew that for us to get to 48, we had to find this angle first. Already you were asked about this angle. So you say, okay, angle M equals to the sum of angles in a triangle. And then 48 will actually be, P1 will actually be 48. Why? Because we have angle at center 2 times angle at circumference. So when you give out answers, it becomes easy when you have already analyzed the diagram. Because you just go through the diagram and you will remember the steps that you actually follow. So we need to master how to analyze the diagram, take out all those theorems that we know, write them down on that diagram of ours. We must show that rainbow. You see it's a rainbow. Yeah, use different colors. The brain remembers color very, very nicely. And then we have the last question that say we have to prove that SP. Where is SP? Let me just use the blue color. SP, here is SP. SP is parallel to QR. And then already when you have SP, you have to prove that SP is parallel to QR. But when you look at SP and then you look at from SP, then I come this side to QR, I have this. Do you see that? Do you see that? SP and then QR, we have a transversal line from P to Q, and we see that this angle is actually equal to this angle. And the positioning will say now P1 is equal to R3, which is equal to 48 degrees. And then how did we get this to be 48 degrees? Then you are going to write how you already got P1. How did we get to S3? Already we have Q, so we're going to use the sum of angles in a triangle, or what we can use that equal chords subtend equal angles. So our R3 was actually 48 degrees because we had this reason. Then you write down that reason, and then because both of them are equal, then we can say yes, my PS is parallel to QR, right? And then we say now alternating angles equal, né? Our alternating angles are equal. That's the reason why we say PS is parallel to QR. Yes. Huh? The R3, yes. The reason was equal cos subtend equal angles. Yes, you can come to P1 first, né? But remember, there was a question that asked you about P1 already. So already spoke about P1. So we know P1 is 48 degrees. Remember, B was asking us what is the value of P1, and we wrote that the value of P1 was actually 48. So we already know that P1 is 48. We just have to tell them how we got R3. And the reason why we got R3, we also asked about Q. So somebody can say, okay, my R3 is equals to, because we don't have that 36, we can use that R3 is equals to 48 because this is 48, and then we have equal cos. Then you say your R3 is equals to 48. Why are you saying that? Because this equal cos are subtending equal angles, and then you write it down. This will be your reason, and then P1 is equals to R3, which is 48. Therefore, we can conclude to say PS is parallel to QR because the alternating angles are equal. Ne? Any questions? Make sense? If you have any questions, please don't stay quiet. There's never a stupid question, eh? Which exit this? Analyze the ice cream. You see that it looks like an ice cream, eh? Just analyze this one. Start with this more information. Check if the information on the statement is the same as the information on the diagram, and then analyze. give you more time?
Yes, sir.
There's also another theorem that has two tangents, eh? This will be tangents run from the same point, eh? The distance from A, so A, P, and BP will be equal. Let me give you more time. I'll give you last 5 minutes. Diagram analysis, write down all you can see. Alright, without answering any questions, let's see what people are saying. In the diagram below, VT and VS, VT. Let's look for VT and VS are tangents with the center at O and T. So already we can also highlight this to say these are equal because those are tangents drawn from the same point. And then we have a circle with the center O, and T and Z are respectively then T, S, R, Z. We have T, S, we have also R, and Z are points on the circle such that TR is the diameter. So we have the diameter this side, which is good. You telling me that these points are on the circumference, it means the points are concyclic together with Y, so we can build our cyclic quadrilateral. Four-sided. I think that's our first one. And somebody can also say, I can make this one two-set. I see my cyclic quads. And then if you can see more, you can also take them out. But this is the one that I've seen so far from the instructions. I'm just checking if the instruction can help you with something else. And then P is the midpoint of chord TZ. We have chord TZ, where's TZ? TZ. So P is a midpoint. So please note it. You're going to need it. If this is a midpoint, please show that this side is equal to that side. And then already you will have those theorems. Now, we're going to start after reading the instructions. The instruction has given us at least a clue of what theorems we actually have. Start T3 is equal to X. You're going to start where there's information. So our point of departure will be where T, the value of X. T3 is equal to X has been shown. Where do we move from T3? Can we move together? Where can we move from T3? S1, Y. There's a tangent. Let me just use black. Look at the tangent. It's not visible. Look at the tangent. And then a chord. And then we will look for the angle subtended by that chord at an alternate segment. So this chord is subtending. We have one angle this side, which is not it. We're looking for an angle that's subtended by this chord, and that angle is this one. Do you see it? So this will be X. And then why is it X? Please be careful with that. The angle, when you're using 10 chord, you must have a tangent. You must have an angle between the tangent and the chord. This is the angle between the tangent and the chord. And that the angle that is equal to that angle will be the angle subtended by that chord that you just mentioned, and an alternate segment. And this must be at the circumference. Yes. Are we fine? Yes. There is? Can I explain why R3 is equals to X? Okay. We are using the 10-chord theorem. The 10-chord theorem says if you have a tangent, let me just do this. If you have a tangent and then you have a chord, there is an angle that is made by the tangent and the chord. Do you see it? Tangent, chord. And then this chord is sustaining an angle, but that angle must be at an alternate segment. It must not be on the same segment as the angle sustained by the chord and the tangent. So it must be at an alternate segment. Hence, we are saying this will be equal to that. Our 10-chord theorem. Next. You look at where you can also put your fingers tangent, go to the tangent, follow it, and then to the chord. This makes a chord now. And then your feet must, your fingers must meet at the circumference. We move to the circumference. Do the same thing for this one. We have a tangent, and then we go to the point of contact. Let's go and meet at the point of contact. Then we make a chord now. Which chord do we have? We have this chord. We move to the chord, and then we need to meet where? At the circumference. Who's going to take us to the circumference? If we come this way, we are not at the circumference. Do you see that? If we are here and we move this way, we are not at the circumference, both of at the same point. Ne? The only way we can move from here to the same point is if we come this side. You see that? Hence we are saying R3 is also equals to X. It makes sense. So we have our first axis here, and our 10 chord is written down. Anything else that you see? Yes. Okay, good. Then we've realized that you are saying something. You are saying this will now be is equals to that, né? Which is also equals to that, right? Aha. So we are saying x will, Z4 will also be equals to x. And as opposite, I should not use yellow. You don't see. Yellow is for slow people, ne? Alright. Let me use blue. We have X. Also this side. Because we say we have angles opposite equal sides. And then we say these are these, ne? We are seeing that. The other one is here. Let's also highlight that one. Anything else? Can we move? 312. Where can we go? Yes. TSR, S1 and S2 is equal to 90 degrees. You're running away from my X, but it's fine. It's good. I also ran away. This will be 90 degrees. Angles on the same cycle, eh? All right. Yes. Huh? Z3 and Z3 and Z4. Also 90 degrees angles on a semicircle. We're taking down everything that we know. 90 degrees, these two combined will give us 90 degrees. Let's try. Now let me ask you, what will be the third angle here? It will be 180 minus 2x, and then we'll have the sum of angles in the triangle. And how is this going to help us? All right. Sorry. Z1 and Z2. Z1 and Z2, we have this angle. Let me try to use it with the red. This angle is also equal to x, because angles opposite. Angles opposite equal sides. If you tangent from the same point, no. But tangent from the same point will tell us if the line these are equal. So you can write tangent from the same point. The reason why you are saying this is equal to that. So we have x, yes. P1, D1 or P? P1, V1. We're saying V1. Okay, let's start this side. You see P? P1 is equal to 90 degrees, so we have 90 degrees this side. We have 90 degrees this side. A line from center to the midpoint of chord. A line from center to the midpoint, we have 90. Yes. You are saying T2. It's saying T2 is 90 minus x. T2 is 90 minus x. Why are you saying that? Why? But how did you, which triangle did you use? This. TRZ. So he used TRZ, which is the sum of angles in a triangle. The other person can also say, I say T is equal to 90 because I have a 10 right. Do you see a 10 right here? Do you see it? A tangent and a radius. If this is x, this will also be 90 minus x. So we can also use the 10 right this side. Okay, we're taking down everything that you can see, yes. A P. Guys, can you be quiet? Thank you. P3. Yes, P3 will also be equal to 90 degrees. This will also be equal to 90 degrees. You can use this as sum of angles, or in a triangle, you can also use vertically opposite angles. Or you can also use the same. Alright. Anything else that you see? It's full, ne? It's full house. Yes, let me just try the back. 04. 04 is equals to x. 04 is equals to x, y. Sorry? Alright, this will also be equals to x. When you sum them up, we have 90 minus x, we have 90, and we have x. We have another one. You want another one? Yes. And then S1 is equals to? Then S1 is equals to 1 over 2 of x, y. It will be angles on the same segment. Angles at center. All right, let's look at it. Let's try to check it. We have x. X is subtended by this arc, red, and then we have x, and then the same thing applies. The side is also subtending this one, hence we are having half of x, and then so we say angle at center equals to 2 times angle at circumference. Next. Let me raise this. I hear some worried voices. Huh? Where? T1 is also equals to x, y, half of x. Okay? One over 2 of x, y. Because the rates are equal, ne? Angles opposite, equal sides. Satisfy, this is 9, this is x, this is 90, this will be 90 minus x. Yes. Z3. Z3 is also 90 minus x. Y. It is angles opposite equal sides, because this is equals to that, this is equals to that. We run out of space. Okay. All right. My first question to you guys, look at the question that we have. Let us prove that TOZV, you can also use our diagram this side. TOZV is a cyclic quadrilateral. TOZV. Let me just try TO. TOZV. Let's prove if TOZV it means that you need to prove in your TOZV, let us try to prove that angle T, this angle plus this angle are giving us 180. So you have x, you have 90 minus x, that side. You also have, you said T3 was 90 minus x, né? And you said the value of T2 and T3 is also x, né? So we have to add the two and see if they are going to give us 180 degrees. Can we add them? Just add them, then we come and write the results, né? Yes. All right. Look at this. Angle T2 plus angle T3 is this angle tangent and the radius, which is 90 degrees. Right? What is our reason then? It is a tangent and a radius. Remember, it's making this angle, né? And then this side, the same thing. So we have Z1, 2, and 3 is equal to 90 degrees. Same thing. Do you see that? Grade 12, you see? Why we use the same thing. And then when you look at these two angles, they are the opposite angles, né? So therefore, these two, which is VTO plus OZV is equal to 180 degrees because VTO is the T2 plus T3, Z123 is the same as OZV. When you add them together, they give us 180. And therefore, we can conclude to say VTOZ is a cyclic quad. What would be our reason? The converse of opposite angles of a cyclic quad. And then we get our answer there. And then how do we prove that RZ is parallel? RZ is parallel to SY. RZ, please highlight RZ from your diagram. RZ is parallel to ZY. SY. RZ SY we need to prove if they are parallel, and then look at this using the same thing, né? We can use the same thing to say I see that I have a 90 this side. I don't know if we can use the co-interior angles this side. This is 90 minus x. This is x, so x plus 90 minus x will give me 90. This is already 90, because why? A line from center to the midpoint of the chord. And then we say the converse of the co-interior angles. Do you see that? Check that one out. This one is very important for you to have that information. We have a 90. We also have a 90 this side. You said this was x. You said this was 90 minus x. And when you add these two, they will give you 90. This will also give you 90. Ne? It off. And then we'll know that the two triangles, the two lines are parallel to each other. Yes. 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 Use the diagram. There's plenty because that's parallel line. Because if there is like and that would be let me see if I can find another way which has spaces. Okay. I'm with you. Guys, look. We have found that x equals to 04 is equals to x, right? We have found that this is equals to x, and then this vertical opposite angles will also be equals to x. Do you see it? So we look at the alternating angles. This has been shown to be x. That's the first angle that we found. So do you see that also alternating angles are equal? So it means these two sides are parallel. So for this question, there's plenty of solution that you can really use, provided we remember that if we have parallel lines, then this will be equal, and then co-interior angles must be supplementary, and then if we have that, corresponding angles must also be equal if the lines are parallel. So from what you have viewed, remember this is what we have seen as the whole class. You will find that not all the angles that are here you have them, but from your diagram analysis, you use the diagram analysis and look at what you have and see how you can relate the two angles that can give you either of these relationships from what you have by highlighting them. As I'm saying, there is plenty of information in the diagram, and then if you can give yourself enough time, you'll be able to point out as many as possible. But whatever you see, when you are satisfied with whatever you have seen in the diagram, you use what you have. And then if you still need more information, your diagram will not be sufficient. Then you'll go back and look at what is actually missing. But in most cases, what you actually see in the diagram will actually assist you to answer the questions. This is plenty of information because it's what we see as the whole class. Because remember, there is no straightforward way to solve a Euclidean geometric question. You need to be able to visualize it. so that you can be able to answer it. So once we have almost all the information now, it's easier for us to plot to see what we can use to actually solve this problem. So now I would like us to go to in your page. This was a grade 11 paper. We have an hour, 30 minutes, by the way. Let's utilize that 30 minutes. That one has an answer book. Ne? I'm going to give you one with an answer book, the grade 12 one. In your supply, let me see how far is it. Look for that question. I think it's Western Cape, because written in Western Cape is not Cape. If we find it. This is now we will test one resource paper. All right, and then when you when 2 pages away, you will have an answer book. You see? 2 pages away from them, you will have an answer book. Yes, it's on page 15. The answer book. And then it's written page 11 at the bottom. So right on the answer, it will come as an answer book. Write the proof construction on the answer book. By that space, you can do that. Don't reference it. Test your brain. Do you see the paper that you have? You see how big is it? I tried to make answer books and I only took 4 question papers. 2 grade 11, 2 grade 12. So the first 2 are grade 11. The last 2 are grade 12. And those are prep and November question papers. So today, tomorrow, Sunday, one problem, just one problem. Nobody will judge you. We will not know, it's you. Nah, it's at home. Yes. Register, don't forget to sign the register. Huh? No, it will come either way. Fine. Today is a long weekend. For some of you. Okay, when you're done, move to the next page on the left hand side. There's a beautiful question that side on the left hand side, just next to it.